everyone. So last week I had an art assessment where I had to copy one of Paul Klee's paintings. So over here you can see there's a painting called Temple Garden drawn by Paul Klee. And for homework I had to imitate and then copy this painting. So I had to draw out all the different regions and I had to do the painting. The only problem was that I'm very bad at doing the sketches. So whenever I do these paintings, so I have to draw out the different regions of the painting. So you can see I had to draw the lines here, 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 and so on. But then that was taken me ages, and I'm not that good at doing these sketches. So I had to find a solution, and the solution is doing some edge detection. So you can see that over here I have two of the images, and over here this is the original painting drew by Paul Klee, and over here this is the result after transforming this edge, so telling the computer to find all its edges and sketching them all out. So this can actually detect the edges quite well. So you can see this is a triangle here, and there's also a triangle there. So this is really, really, really good software. But how does all this even work? How does it work? Well, we have to all start with what is an image. So with an image, it's all made up of pixels. Pixels are the colored squares. So they're positioned right next to other pixels inside an image. So an image has thousands and thousands of pixels. And every single one of those pixels can have individual colors. So the computer stores the pixel, so the color of the pixel, in terms of a combination of red, green, and blue. So over here, I have 0 red, 0 green, and 0 blue. So it's going to be black. And you can pause this video and guess what would happen if I had a 1 for the red value and the other is a 0. Well, you guessed it, it's going to be red. And you can have a red and a blue, which will give you a sort of purple. And you can have a red, 0 red, and some green and some blue. And you get a greenish blue, sort of turquoise-ish color. So now that we understand how pixels work, let's look at this. So in order to detect an edge, we need to tell the computer how different the colors are relative to the ones next to it. So over here, I have an image of Mario, and you can see that in order to detect the edges, you have to compare every single pixel with the pixels around it. So let's look at this pixel right here. So the white pixel right there. So you can see it's all of the pixels around it are very different from each other. So this white is different from this pink, this yellow, and the other pixels around it. So it will be detected as an edge. So if the adjacent pixels have a big difference in color, the program will draw an edge. So it will draw an edge to signify that there's a big difference in color between the adjacent pixels, the pixels next to each other. So over here, the program analyzes every single pixel with the pixels around it, and it calculates the quantified difference in color. So it calculates the quantified difference by finding the red value of both of the pixels around it. So if you have two pixels that are right next to each other, they calculate the difference in the red value, difference in the green and the blue, and sort of averages it out. So you can see over here, if it is small, so it will be 0.00 something, and if it's bigger, it will be 0.24. But then all of these data aren't really meaningful to us. So the numbers are meaningless. We want all the data, all of the differences between the pixels, to give us something that we can analyze. So all the quantified difference actually gives us this image. So we have a black background, and once there's a difference between the colors, so if the difference is relatively big compared to the differences around each other, so this pixel right here would be quite a big difference. It's 0.24 and 0.3. But the ones around it, maybe here, aren't as big. So it will draw an edge like this, an edge sort of sketched in white. The only problem is that it's not that good to have a black background. That's because I wanted to print this image out and use it to do the edges for my outline. And it would be sort of wasting all your ink if it is black. So I had decided to sort of invert all the colors. So I turned the black into white. So all the edges that in white will turn into a black or a grey color. So what I did was I defined a function called sketch to calculate the opposite color. So like, since 1 is the maximum, so like 1 minus that will give you the inverse of the color. And I mapped it. So like, I turned all the black into white and all the white into black. And the blacker it is, the bigger the difference. So sometimes, you see over here, it's just a gray, but right next to it, over here, this is actually a black color because the difference of the colors between the adjacent pixels, between the pixels right next to each other, are very different here and not as different over here. So, and this is actually how my program helped me to do my arts homework. My program actually helped me a lot because I was able to like easily draw the outlines so that I could draw the watercolors way easier. And I actually got an exceptional for this piece of art because of my program. So hopefully this sort of inspires you to learn code. So like with code, as long as you put enough effort into it, you'll be able to use the code and apply it into your daily lives. So I applied the code to help me do my art with as little effort as possible. Okay, but that's it for this video, and bye! I don't know. So now you have a basic understanding and some intuition to how some of the code works. So over here, you now understand that this is a sketch function. So how it works is that you detect all the edges with a black background, and what this does is that it inverts and reverses all the colors. So the black becomes white. So this all makes sense. The only question you might be asking is, how did I even detect the edges with the black background in the first place? So what I just said was actually just half of the story. So there's a lot more code to explain how all of this works. So now let's take a look at how the code works. You can see over here I had to define many different functions other than a sketch. So I had to calculate the brightness value, and I had to calculate the convolve. Convolve is just turning an image into something else. And over here, this was how the computer program actually detected the edges. It detected the brightness of them, and then they sort of found a difference. So like, if the brightness is different, then the colors must also be different. So, and once the colors are significantly different, this function, edginess, will detect all the edges. And so in order for me to put several of the images next to each other, like this, and also with a sort of tiny sliver between them, I'd use a function called hbox. Hbox is just a function where you take the two images and you sort of fill the gap in between those images with white. So that's about all of the code. And those of you that are curious and wants to explore the code, and maybe you want to have a portrait of yourself and have your own face and detect all the edges of your face. So I put all my code onto GitHub. So over here, inside my TinFungster GitHub page, that's my account, and over here, at a repository called School Projects, and the file is my presentation, and that's my class.jl. So over here, this actually looks quite weird. So what Pluto does is that it turns all of these and turns it into a Pluto notebook. So all you have to do is you have to go and copy the URL, copy it, and you have to paste it into the open from file. And it'll say, are you sure? Of course you're sure. I made this notebook myself. So you have to open it, and it'll help you run all of the code, and it'll help you run all of the code, and you can even experiment with this. So you can actually have a different picture. So you can replace this Polkly with an image of maybe your pets, maybe a dog or a cat or whatever. So you are free to use my code, and you can change the code so that you probably learn some coding along the way. And some of you might actually not have Pluto installed onto your computer. So there's another way for you to be able to run a file. Don't worry. So over here, you just need to go to GitHub and search fonts Pluto.jl. You search the repository Pluto.jl, and you'll get this repository, which is made by a guy called Fonts. So this is Pluto.jl, the software that allowed me to run all this software. And you just need to click on the Pluto demo inside your browser. This way you don't have to install anything. And once you use the binder, so it will make a Pluto demo inside the browser, as it just said, and you just have to follow the same steps. Over here you have a Pluto demo inside the browser. So it's a binder link, and you just need to open from File, and just open it, and it will help you to run the file inside a browser, even though you don't have Pluto installed. So the only problem with the binder is that you're unable to save your changes to this. So if you want to run a file, you have to save it into GitHub, and it will make stuff really, really, really annoying. So as you can see, I just opened the Pluto notebook inside my browser using the binder link that you just clicked at, and you can see I can run pretty much all of the code. And you can see the edge detection is there, and you can see that I have the two images over here. So over here, even without installing Pluto, you can still run the code inside this binder website, which makes it really cool. So if you're using a Chromebook, you'll be unable to install Julia and Pluto, but you'll still be able to have and enjoy the fun of writing the code inside a Pluto notebook, which I really, really, really admire. And so my code was actually based on the image processing course at MIT. The course is called MIT 18.S191, and so you might have noticed that this uses a Pluto environment. So I taught you how to install Pluto in the last video, and I actually installed several packages. So I had to use images, Pluto UI, image filtering, and some packages pre-installed with Julia, so statistics and linear algebra. And for my art project, so for my assessment, it was actually just a tiny part of the Temple Gardens image. So I found the image from the internet, and I had to crop it down to the only area where I needed to use to draw the painting. Thank you for watching. That's it for this video. See you in the next video. Bye!